In this video, we are going to find the inverse Laplace transformation of that function. This is a good example when the poles are complex number. So by complex number, we mean that if our pole is in the form of minus a plus jb. So if our pole is a complex number, then we can factor out our denominator in the form of s plus a square plus b square. And once we do that, we have to find the ps in this relationship, s plus a square plus b square multiplied by fas. And once we do that, we can then find p minus a plus jb. And when we find that value, our original function will be equal to the magnitude of p minus a plus jb divided by b multiplied by e to power minus at sine of bt plus the argument of p minus a plus jb, which the argument of p minus a plus jb will be the tangent inverse of b divided by a. So let's now use this and find the inverse Laplace transformation on that. So the first step is to find the poles. So we said s2 plus 2s plus 10 equal to 0. So our poles s1 and s2 will be equal to minus 2 plus or minus the square root of 4 minus 40 divided by 2. So this will be equal to minus 2 plus or minus 6j divided by 2. So the answer will be minus 1 plus or minus 3j. So our poles are in this form. So here our A is 1 and our B is 3. So the next step, we know that our denominator can be factored out in this form. So our denominator can be factored out as s plus 1 square plus 3 square. So the next step, we find the value of ps in this relationship. So our ps will be equal to s plus 1 square plus 3 square multiplied by fs, which is s plus 2 divided by s plus 1 square plus 3 square. So these two terms will cancel out, and our ps will be equal to s plus 2. Now we have to find p minus a plus jb. That means p minus 1 plus 3j will be equal to, that means we have to put that value for s will be equal to minus 1 plus 3j plus 2. So our p minus 1 plus 3j will be equal to 1 plus 3j. So once we find that value, then we can, our original function f(t) will be equal to magnitude of p minus 1 plus jb, which is that magnitude of that will be a square root of 1 square plus 3 square divided by b, or b is 3 multiplied by e to power minus at, or a is 1 multiplied by e to power minus t, sine of bt, sine of or b is 3 sine of 3t, plus the argument of p, the argument of that, plus tangent inverse of 3 divided by 1, which we can find the tangent inverse of 3 tangent inverse of 3 will be 71.6 degree. So this will be plus 71.6 degree. So let's write this as the square root of 10 divided by 3. So this is our original function. In next video, we will look at the example that the poles will be a combination of the real and complex number, and then we are ready to move on into actual engineering problems. See you.